So now we're going to try and simplify this left-hand sum. We need some background. So additional background on summations that's going to be useful to us. Again, it's one of these things that seems like it might be obvious, but you can't take a lot of these things for granted. Well, let's look at the sum of, from I equals 1 to n, of the sum of a sum of things, right? Because that's what we have here. Is we have a sum, and it's going to end up with a sum in it. A sum or a difference, all right? What can I say about the sum of a sum? Well, if I have just a simple a sub I plus b sub I, then think about what that means. That means a1 plus b1, that's when I equals 1, plus a2 plus b2, that's when I equals 2, plus a3 plus b3, plus etc. up to an plus bn. All right, now we can use the commutative and associative properties of addition and just group all the a's together. A sub 1 plus a sub 2 plus a sub 3 plus up to a sub n plus b sub 1 plus b sub 2 plus b sub 3 plus up to b sub n. All right, so all I've done is regroup the a's and the b's, and then this is what we call the sum from I equals 1 to n of a sub I, and this is the sum from I equals 1 to n of b sub I. So all that is to say that if I have a sum of sums, I can split that sum over the sum. And then by extension over the difference, since a plus bi is a plus a minus bi would be a plus negative bi, so you can sort of do the same thing. All right, so with that in mind, let's start working on this thing. So our area from the left is equal to the sum from I equals 1 to n. You can sort of break it down, split it up as much as you can on your own, and then check back. So I'm going to start by calling it, I guess I'm going to leave this like this so that I can do this in a separate step. All right, so the first thing I'm going to do is factor out the 8 over n cubed just like we did before. And then I have sum I equals 1 to n of I minus 1 squared. All right, and then I'm going to keep that 8 over n cubed out there, and I'm going to square out the binomial I squared minus 2i plus 1. All right, now that's where we're going to be able to use this. So we can say this equals 8 over n cubed times the sum from I equals 1 to n of I squared. And then using the property we got before that, I can factor out a constant minus 2 times the sum from I equals 1 to n of I. And then I just have plus sum from I equals 1 to n of 1. All right, so let's try and figure out what each of these things are. You can try and figure out what each of them are, but it might require a little discussion. So this equals 8 over n cubed. So this one we already know. We already did sum from I equals 1 to n squared, so I have n times n plus 1 times 2n plus 1 over 6. That's what this one is. And then I'm going to have minus 2 times. All right, this one, you know what I'm going to do? Well, no, I was going to distribute out the 8 over n cubed. I'll do that in a later step. Okay, so 2 times n plus 1 over 2, right? And then plus, where did I get that from, huh? Where did I get the n plus 1 over 2? Got it from here. Remember this guy? Sum from I equals 1 to n of I is n over n plus 1, n times n plus 1 over 2. All right, that's where we got this goes to this. All right, now you tell me, what do you think the sum from I equals 1 to n of 1 is? What do you think it is? Well, what that means is I'm going to go 1 plus 1 plus 1 plus 1, and I'm going to do that n times. So what am I going to get? I'm going to get n. All right, sum from I equals 1 to 7 of 1 is 7. Sum of I equals 1 to n of 1 is just n. All right, let's distribute out the 8 over n cubed, and maybe we can simplify things a little bit. We could really simplify this one a lot because we already simplified that one. So this term right here, that's what we had last time, right? So we can just go ahead and cut to the chase on that one. We already know it's 8n squared plus 12n plus 4 over 3n squared. Okay, now let's work this one out. All right, so the 2's are going to cancel, right? Oh, yeah, the 2's are going to cancel. I can cancel the n cubed with the n and get an n squared in the denominator. So, and then so remember I'm distributing this 8 over n cubed with it. I was going to do that separately, but I didn't. So if I distribute out the 8 over n cubed and cancel the 2's, I'm going to get 8 n plus 1 over n squared. The n cubed reduces with the n to give you the n squared. The 8 is here. The n canceled with one of the n cubes to give me n squared. That's how that went. All right, and then when I do 8 over n cubed times n, I get 8 over n squared. All right, now let's get a common denominator for these guys so I can put them all together. So I'm going to keep, the common denominator is 3n squared. So I'm going to keep 8n squared plus 12n plus 4 over 3n squared. I'm going to keep that the same. This one I want a common denominator of 3n squared, so I'm going to multiply top and bottom by 3 and get 24n plus 1 over 3n squared. And same here, multiply top and bottom by 3, 24 over 3n squared. All right, you can definitely simplify it from there. So if you want to simplify it from there. It comes out to be 8n squared minus 12n plus 4 over 3n squared. That's what that simplifies to be. All right. Now, that gives us the sum from I equals 1 to n of a sub I for any left-hand sum of f of x equals x squared on the interval 0 to 2. It's given by this formula. Same as we had one for the right-hand formula. In fact, you can look at the similarities between this and the right-hand sum. They're very instructive, and we'll talk about it later. By the way, you can find the limit. What's the limit as n approaches infinity? That is our next number 7. Factor out all terms of n, use formulas to convert. We did that. Simplify as much as possible. Find the limit as n approaches infinity. See you on the other side.